Imagine this. You walk into your living room after a long day. It's dark, and you're tired. Instead of fumbling for the light switch, blindly searching in the dark, you simply say, "Hey Google, turn on the lights." Instantly, the room lights up, welcoming you with a warm glow. Or maybe you're driving, stuck in traffic, and need to send a text to let someone know you're running late. Keeping your hands safely on the wheel, you say, "Hey Siri, text my mom I'm on my way." The message is sent, hands-free, eyes on the road. It feels like magic, a seamless blend of technology and convenience, but it's just technology that's gotten really good, incredibly sophisticated, and surprisingly intuitive. These devices, the ones we use every day, your phone, always within reach, your smart speaker, a constant presence in your home, even your watch, right there on your wrist, are packed with voice assistants, Siri, Alexa, Google Assistant, and more. They're like digital butlers, always ready to help, anticipating your needs. We use them to set timers while we're cooking, play music to set the mood, or settle debates with a quick fact check, proving our point in seconds. Their main goal? Convenience, pure and simple. But have you ever wondered, even for a moment, what's actually happening behind the scenes when you talk to them? You speak, and it just works, most of the time anyway. Behind that seemingly simple interaction, that effortless command is a complex chain of hardware and software, a symphony of engineering, working at lightning speed, processing your request in the blink of an eye. It listens intently, understands the nuances of your words, thinks critically about what you're asking, and acts decisively, all in a split second, a feat of modern engineering. The leap from clunky robotic commands of the past to smooth, natural conversations is huge, a testament to technological progress. These assistants are now seamlessly woven into our daily routines, managing schedules, controlling smart homes, and simplifying our lives. So let's break it down, shall we? Let's peel back the layers of complexity and see how these digital assistants really work from start to finish. No jargon, we promise, just a clear, concise look at the tech behind the magic, demystifying the process. Ready to explore? Let's dive in and uncover the secrets. This is the story of how your voice becomes action, transformed into commands and results, and why it's fundamentally changing the way we live, work, and interact with the world around us. Ever wondered how your smart speaker seems to know exactly when you're talking to it? It's a pretty clever process. Contrary to some concerns, it's not constantly recording everything you say and sending it to some server. That would be a massive privacy violation and a huge waste of processing power. Instead, it operates in a low-power, always-on mode, carefully designed to minimize energy consumption. It's constantly listening, but only waiting for one specific thing, the wake word. Think of it like a dog instantly perking up its ears when it hears its name being called. A tiny dedicated chip is always on the lookout, listening intently for a very specific sound pattern. Something like Alexa or Hey Google, depending on the device you're using. At this stage, it's not actually understanding language or the meaning of words yet, it's simply matching sound patterns to a pre-programmed template. Once it successfully identifies the wake word, the device fully wakes up from its low-power state and starts processing your request. You'll typically see a light or some kind of animation. It's the device's way of visually indicating, "Okay, I'm listening now, go ahead." Everything that was said before the wake word is generally ignored by the system and is never recorded or transmitted. The actual recording and processing of your voice command starts only after the wake word has been detected. For this system to work effectively, the accuracy of the wake word detection is paramount. If it's too sensitive, the device triggers by accident, leading to frustrating false positives. But if it's not sensitive enough, it misses your commands entirely, making the device seem unresponsive. That's why companies invest significant time and resources, often years, fine-tuning this delicate balance. It's a crucial first step in making voice assistants feel truly seamless and effortless to use. You've said the wake word. Now what? Your voice, just sound waves, needs to become something a computer can understand. The microphone and a converter turn your speech into digital data. This audio is sent through automatic speech recognition, or ASR. ASR breaks your speech into tiny sounds called phonemes and matches them to words. It handles accents, mumbling, and background noise, comparing what it hears to a huge database. The result? A text version of what you said. This all happens in a split second, so the interaction feels natural. Fast, accurate ASR is why voice assistants work so well. Without it, nothing else would function. Now, the assistant has your words, and it's time to understand them. The assistant has your words, but what do you actually want? Enter natural language processing, or NLP, the real brain. NLP figures out your intent and the details or entities in your request. For what's the weather like today? The intent is to get the weather. Today is the entity. Ask the same thing in different ways. Do I need a jacket? Or, will it rain later? And NLP still gets it. It's not just matching keywords, it's understanding meaning and context. Once it knows what you want, it fetches the info, like checking a weather service. Then it turns the answer into a natural-sounding reply. That's how you get your answer, fast and conversational. It's what makes talking to your assistant feel human. Here's where it gets smarter. Voice assistants learn from every interaction, yours and millions of others. Each command is a tiny piece of training data. If it gets something wrong, like mishearing a song, your correction helps it learn. Engineers and automated systems review anonymized data to improve accuracy. It also learns your habits, like your morning routine or favorite contacts. The more you use it, the more personal it feels. This feedback loop data analysis refinement makes assistants better over time. They adapt to accents, new phrases, and even recognize different voices in your home. The assistant you use today is smarter than last year's thanks to this constant learning. Machine learning is the engine behind the magic, and it never stops improving. Where does all this processing happen? On your device or in the cloud? For years, most of it happened in the cloud. Your command sent to powerful servers, then the answer sent back. The cloud means more power and instant updates, but it needs an internet connection and adds a slight delay. Now, devices are getting smarter. With better chips, simple tasks like setting a timer can be handled right on your device. This means instant responses and offline functionality. The biggest win? Privacy. Local processing keeps your voice data on your device, but for complex questions, your device still needs the cloud. The future is a hybrid, fast, private, and powerful. You get the best of both worlds. The line between device and cloud is blurring, and that's making assistants faster and safer. With all this convenience at our fingertips, as we seamlessly integrate these technologies into our daily lives, privacy is the big question. It's a concern that looms large as our digital footprint expands. Devices only listen for the wake word locally. This is the initial gatekeeper, ensuring that not every passing sound triggers a recording. After that initial trigger, your command may go to the cloud, where it's processed and analyzed to provide a response. Companies now offer clear privacy controls, giving you more power over your data than ever before. You can review, taking a look at what's being recorded and stored, delete, or opt out of voice data collection altogether, if you prefer a more private experience. The more data assistants have, the more helpful and personalized they get, learning your preferences and anticipating your needs. But as the data pool grows, privacy risks grow too. It's a delicate balance. On-device processing is a direct response to these concerns, keeping sensitive data local and minimizing the need to send information to the cloud. Security matters. It's the foundation of trust in these technologies. Your data is encrypted on the device and in the cloud, adding layers of protection against unauthorized access. Voice assistants will only get more integrated into our homes and lives, becoming central hubs for managing our connected world. More conversational, understanding the nuances of human language. Proactive, anticipating your needs before you even voice them. And context-aware, understanding the situation and responding appropriately. Imagine an assistant that knows your schedule, keeping track of appointments and commitments, and adjusts your alarm for an early flight, ensuring you get to the airport on time, even without you having to manually set it. The tech is amazing, pushing the boundaries of what's possible. But users must stay informed about the implications of using these technologies. Know how it works, understand the data it collects and how it's used, manage your privacy, take control of your data and customize your settings, and use it wisely, being mindful of the potential impact on your privacy and security. The future is smart, filled with incredible possibilities, but it's also about trust, building a relationship with technology that's based on transparency and respect. Voice assistants are powerful tools capable of transforming the way we live and work. Let's use them thoughtfully, ensuring that they enhance our lives without compromising our values. The choice and the control over how we use these technologies is yours. It's up to each of us to shape the future we want to see.